Hi guys, today we're going to learn how to integrate and differentiate bases other than E and applications. So in Algebra 2, what you learn is y is equal to log base b of x means x equals b to the power of y, where b and x are greater than 0. What we're going to use here is review some Algebra 2 stuff, Algebra 2. Okay, so we're going to solve for x. We're just going to solve for x. We don't need the calculator. Okay, so you're going to solve for x these two problems. Let's start with this one. Okay, so you have base 2 to the power of 3x equals 45. So what we're going to apply here, both sides, is log of 2. Okay, so if we apply log base 2 of this, okay, and log base 2 of this, what we have is that pretty much these two would cancel, leaving the 3x alone. So you have 3x is going to be equal to log base 2 of 45. Okay, so resulting this in what? X is going to be equal to 1/3, because I divide both sides by 3, log base 2 times, or 45, excuse me, not times. Okay, so this would give you some crazy number. Okay, so that will be it for this one. Okay, so for B, what you have is you have log base 5 of x minus 2 is equal to 3. So what you're going to do here is pretty much put the big 5 here, the base. Okay, why 5? Because that's the base. And the big 5 here and the log base 5, they cancel, so you would have x minus 2 on this side, and on this one you know that 5 to the power of 3 is 125. Okay, therefore you add 2 to both sides and you have that x is equal to 127, and those are pretty much the properties of exponentials and logs when you move from one to the other. Okay, so let's review the new formulas that we have for the day. Okay, some old formulas that you have from previous days are the derivative with respect to x of natural log of u is equal to 1 over u du dx. This one is pretty close to the derivative with respect to x of log base a of u is going to be equal to, look at that, 1 over u. It's exactly the same as this 1 over u. The only new part that we have over here is the natural log of a. The du dx is exactly the same du dx that you have here. So technically speaking, what you have new, and I'm going to put the highlighter there, it's that part. Okay, the rest is pretty similar to the one for natural log. Now on the other hand, you also have that the derivative with respect to x of e to the u is e to the u du dx. So something that is very similar to this one is going to be the derivative with respect to x of a, base a, to the power of u. And this is going to be equal to base a to the power of u, natural log of a du dx. So as you can see, this guy is like this guy, the equivalent of this one. What you have new is the natural log of a that you have there multiplying the exponential part. Okay, so that's what we have. Okay, so the next one that we have is the integral of e to the u du, which is equal to e to the power of u plus c. So something very similar that you have for bases different than e is that when you have base a, you are going to have the integral of a to the u du. This is going to be equal to a to the u, and not only that, you are going to divide by the natural log of a. Okay, so you can see that that's the difference between this formula and this formula. So the pink part that I just highlighted is the difference between the formulas that we learned on previous days and the formulas that we're learning today. Okay, so let's apply this formula so you can see they are very user friendly. Okay, so let's take the derivative of y equals 2 to the power of x cubed. So what's going to be the derivative of that? It's going to be itself as it is times the natural log of the base. In this case my base is 2 times, okay, so all this times the chain rule, okay, so which is going to be the derivative of the exponent, which is 3x squared, and that's what we have. Okay, you can pass this in front, you can do a lot of things, but it's a multiplication, so it's commutative, so it really doesn't matter who you put in front and all that show. Okay, so leave it like that. This one, you have that it's f of x is log base 3 x squared plus 1. So what you have is the log is going to be 1 over, okay, whatever you have there, which is x squared plus 1. Then this one is going to be times, okay, the base, okay, natural log of the base, natural log of 3. Okay, so I'm going to extend this one times the chain rule. It's going to be the derivative of the inside of the log, which in this case it's 2x. Of course, you can put this 2x here at the front, and that would be the same. Okay. So let's look at the integrals. Okay, so when you integrate something that looks like this, you have that the integral of 2 to the power of x dx is going to be equal to 2 to the power of x divided by natural log of 2 plus c, and that's pretty much it because you don't have anything else to do. Okay, this one was pretty clean. Now, something that looks a little bit intimidating like this one, what are you going to do? What you can do here is always use u sub. Okay, so u is going to be what? The most annihilated part of this function is going to be x to the power of 3, that it's inside the base, the exponent of the base of 3. Okay, so you have that that's going to be your u. Your derivative is going to be 3x squared dx. Do you agree with that? Now you can see that we don't have this 3, right? So we need to divide by 3 here. So I would divide, but I don't have space, so that's why I'm putting here the 1 over 3. And then the x squared, I have it here, and the dx, you have it here. So this one, check and check. So those, I don't need to complete anything. So you have 3 to the power of u du. So here you can apply the formula beautifully. So when we apply the formula, you have that it's going to be 1 over 3, okay, and then we have that it's going to be 3 to the power of u divided by natural log of 3 plus c. But that's not it. We do need to take care of the u, right? We need to go back to our original. Our original is going to be 3 to the power of x power 3, everything divided by 3 natural log of 3, and then plus c, and that's going to be your answer. Okay, so if you're asked to differentiate a function that contains a variable raised to the power that contains a variable, we have no formula for this, but you must use a process called logarithmic differentiation. So as you can see here, we have y equals x plus 1 to the power of x minus 3. You need to find dy dx in terms of x. So what are we going to do over here? Pretty much like in algebra 2, you are going to apply natural log to both sides, having natural log of y is equal to natural log of x plus 1 to the power of x minus 3. So what you're going to do here is you are going to pass this exponent to the front, having something that looks like this. Natural log of y is going to be equal, and you have that it's going to be x minus 3 times natural log of x plus 1. So what we're going to do at this point, okay, you have that you release the x from the exponent, and now it's here. So we're going to take the derivative with respect to x of both sides. Okay, so what we have here is something that looks like that. Now you're going to tell me how in the world you expect me to take the derivative of natural log of y. Well, you can do that implicitly. You have that it's 1 over y dy dx is going to be equal to, this is going to be a product, so you have that it's the first one times the derivative of the second one, which is 1 over x plus 1, okay, close it, plus the second one, natural log of x plus 1 times the derivative of the first one, which is just 1. So you have something like this, right? So ask yourself, do you see dy dx? And the answer is yes, it's over here. The only thing is it's not alone. So what are you going to do with the 1 over y? You are going to multiply both sides times y, so you can cancel out this one. Having dy dx is going to be equal to what? Put a big parenthesis, x minus 3 divided by x plus 1, okay, because I just stacked this 2, plus natural log of x plus 1 times y, okay? So at this point, you're like, okay, are we done? Well, read the problem. Find dy dx in terms of x. The problem for this y is that you have to replace the y with x's. And you're going to tell me what is y, and the y is here in the hypothesis. Y is equal to x plus 1 to the power of x minus 3. So you just go ahead and replace that y. Let's put it here. Dy dx is going to be equal to the same, okay, situation that we have here, monstrosity, okay, over here. And then you just multiply that times the original, which is x plus 1 to the power of x minus 3, and that's going to be your derivative. Okay, so I hope that you find this video helpful. Bye.